Good morning. Happy Friday, everyone. Thank you very much. It's great to be here in Berlin today. Thank you for being here. My name is Fabian. I'm CEO and co-founder of Keyless, the pioneer and leader in privacy-preserving biometric authentication. So today I'd like to talk about an important topic, securing user identity across the entire digital lifecycle, from the initial enrollment throughout ongoing authentication, in the most simple, secure, and privacy-preserving way. Unfortunately, the way we authenticate users today is fundamentally broken. We're all reading about staggering numbers in account takeovers, continued data breaches and hacks, dissatisfied users, or escalating support costs. If I'd ask you, when was the last time you had to reset your password? Or you struggled receiving that SMS OTP to complete the MFA challenge? Maybe you live in Germany and you're still waiting for that activation code that your bank should have sent with a letter to your home address so you can recover access to your account. I imagine many of us can relate. Now, this is even becoming more complex. It's no longer just about stealing your password. It's also about swapping your face or cloning your voice. AI-generated fraud is becoming one of the biggest threats to businesses today. Deepfakes, voice cloning, synthetic identities, these are no longer sci-fi concepts. They're real, scalable, and dangerous. One of these numbers should scare you, $40 billion. That's the number of fraud losses that Deloitte projects AI-generated fraud to deliver by 2027. And banks are already seeing this pain. I imagine many of you have heard about the story of a Hong Kong financial institution last year that was defrauded for $25 million because scammers created a completely fake meeting with fake people with deepfake technology to trick an employee to wire out that large sum of money. And organizations are seeing this challenge in today's world. More than half of crypto firms today have already encountered deepfake fraud. At the same time, 60% of organizations report that they're dissatisfied with their own account recovery methods. So account recovery or device activation or reactivation remains one of the weakest links in the authentication chain across the lifecycle. And all of this isn't a surprise because we're relying on fragile tools, passwords that are reused, SMS OTPs that are phishable, hard tokens that we share or lose, and call centers that, one, are expensive, but two, are frustrating for all of us. Now, we believe biometric authentication has the potential to solve that gap, but when implemented correctly. Today, we can classify biometric authentication systems in two categories: the device-native or local biometric approach, where both enrollment and face matching has happened locally on the device, and the server-side or centralized biometric approach, where enrollment and authentication happens remotely on a server. Each of these approaches has their advantages and disadvantages that I'd like to look at now. Starting with the local or device-native approach, it's great because there is no biometric data that ever leaves the device. So it provides that security and the privacy of the user being in control of their own sensitive personal information, their biometric data, because it's stored on their own device. The huge disadvantage here, though, is that we're not really authenticating the individual. The remote service we are authenticating into doesn't know who the person behind the device is. I imagine many of you, when you've upgraded your phone or you lost your device, you realized that you had to re-enroll your face on the new device that you're using. Now, this can be achieved with a server-side or centralized biometric approach, where that authentication process doesn't happen on the device, but remotely on a server where that template is stored. So we provide that strong link of the real person behind the device and essentially the person that we're authenticating into the remote service. So we verify the user's identity. However, that comes at the great expense of having to store all this sensitive personal information in a central database. So from a security risk or compliance perspective, we're running into severe issues. Now, what if we could combine the interoperability and the usability benefits of the server-side biometric approach with the security and privacy benefits of the device-native or local biometric approach? This is what we've done at Keyless, and we call this paradigm zero-knowledge biometric authentication. Now, we've been working with Gartner, in this case, for a few years to create a new category which Gartner calls decentralized biometric authentication. They loosely define it as a category where no single party has full control over the biometric information, achieving, or with the aim of achieving, a better balance of usability, security, and privacy through the use of so-called privacy-enhancing technology, or a fancy word for cryptography. Now, the keyless approach to this decentralized model is not just a system where no single party has full control over the biometric data, but it's a system where no biometric data is stored at all. So what happens technically is when the user looks into the camera of their device, is that we capture the biometric features, we transform them locally on the user's device through a one-way cryptographic function using a multi-party computation scheme into a cryptographic quantity that cannot be reversed, but that also cannot be linked to the individual. So neither us as the service provider, the organization who would run and host this on-premise, or the user themselves have access to the information. There's no biometric data or no signing key that is stored anywhere, neither on the user's device nor anywhere on the server. The other characteristic of the system is that it provides an inherent multi-factor security. We verify both the user's device that is cryptographically tied to the account at the point of registration or enrollment, distinct and independent of performing passive liveness and server-side face matching. So we're combining two factors with one look into the camera, but to the user it looks and feels like Face ID, and it does so across any end-user device, the only requirement being a 720-pixel capable camera. Now, part of every authentication, every good biometric method is obviously assuring that the user is a real human, not a deepfake video injection attack or someone with a mask. So as part of every authentication, we provide passive liveness detection, which passive meaning being completely passive, there's no user action required, no looking left, right, smiling, blinking, no nodding, no moving back or forth, no colors, no flashlights. Really an experience that Face ID delivers with the superior sensors that the iPhones have, which is overlaid with additional signals, behavioral elements, so we measure micromovements, the accelerometer gyroscope to assure that it is a real human, not a video or deepfake. Now, as part of the face matching, one of the things you may look at when evaluating biometric vendors is the FIDO benchmark for the component certification around biometrics, which sets thresholds for false reject rates and false accept rates at 3% at an equal error rate of 0.01%, and assesses the presentation attack detection against the ISO 30007-3 requirements, or the equivalent IBETA level 1 or 2, which we have as well. In addition, you may want to look at the NIST rankings. Biometric vendors can submit their algorithms to NIST, which benchmarks these algorithms. We rank among the top 50 in the one-to-one category, top 11 in the one-to-many category. Notable to mention that many of these algorithms are not commercially used, come from countries like China or Russia, so from labs, but that is an open public source you may want to look into. Another source, obviously being here in Europe, is ADAS and the component certification, the module certification for the assurance level highest, which is another thing you may want to look at. And obviously, customer references, banks, and we've been meeting regulators, and operate in some European countries with the possibility of not requiring explicit user consent because there is no biometric data that we store. Now, talking about securing the entire lifecycle of the user, biometric authentication, or authentication in general, is really more than passwordless login, which is often talked about. It starts with the initial enrollment, obviously covers login procedures, but then goes across the lifecycle for use cases such as securing high-risk events. Think of changing address information, adding a phone number to your account, or changing your card data. Securing payments or signing transactions against the open banking or strong customer authentication requirements, which mandate multi-factor authentication and dynamic linking to sign the transaction for the audit trail of the bank. And then the account recovery or device activation use cases, which often involve the call center, involve the user having to physically show up in a branch, or a complete new KYC or IDV flow from the start. Now, talking about these enrollment options, there are also multiple ways we can enroll a user. And we can distinguish between active enrollment processes and a passive enrollment process, which is very elegant, that I'd like to touch upon in more detail in a second. On the active enrollment side, obviously when talking about biometrics, there's the new way of using the digital ID card, extracting the selfie image through the NFC chip, and basically assuring or verifying the user identity that way, which is one of the active options. The other option is just a live capture of the face, similar how you add your face onto your phone, where you look into the camera, the template is created, in our case, that cryptographic key material, which is then stored server-side for ongoing authentication. The passive option, which we call IDV bridge, to bridge IDV, identity verification, and ongoing authentication, is a model where we're able to tap into existing selfie images that an organization may have on file from digital onboarding processes, the result files of the KYC where we could crop the image, and enroll these existing selfies in the background through this IDV bridge component and generate that cryptographic key material that we then authenticate completely passively or silently in the background. So if you've went through a digital onboarding process with an organization, and that organization would use keyless for ongoing authentication, you wouldn't be required to register yourself into keyless, but we can do that in the background by leveraging the selfie that already exists in file, and through that bridge both IDV and ongoing authentication. In today's world, and that is what drives those challenges we see, especially in the consumer side, is that these domains are completely siloed. We go through a robust IDV process where we create the identity and establish a very strong binding between the real-world person and the digital twin or the account that is created. But then when we authenticate into that account, we use credentials such as username, password, and SMS OTPs, which basically drive the challenge we have. Now, what we're able to do with this IDV bridge component is tie these together in a very seamless and convenient way, leveraging those existing selfies and running this component on-premise where those selfies reside, so no biometric data ever leaves the perimeter of the organization. And then ongoing authentication doesn't introduce any risk from a PII perspective in authenticating the user or verifying, continuously assuring the user's identity, no matter what device or channel they're coming from. In addition to the consumer cases I've talked about, we also offer a solution around workforce authentication. Certainly the plain vanilla use cases for passwordless login or authenticating the remote employee when accessing sensitive pieces of information or systems. But one very interesting use case we're finding is the ability to authenticate multiple employees on a shared device. Think of frontline workers, kiosks, point of sale, where there may not be the need or the possibility of using a companion device to authenticate that person, Android Zebra devices in shops, or a kiosk or tablet at the store, whether the employee is able to look into the camera of that device and authenticate into the IDP or any connected application in a convenient way, assuring that it is that very person who is authenticating. So now I'd like to show a few examples of these use cases on both the consumer and the workforce side to give you a feel of how that looks like in practice. Now, starting with the device activation or reactivation journey on the consumer side with a large bank or the largest bank in Italy, we're having a user who has a new device and wants to recover access to the account and tie this device to his or her account, in this case, her account. So comes in, downloads the app, clicks on Link My Device, puts in their personal code, so any unique identifier, puts in their PIN. This is optional. If the user forgets the PIN, they can recover the PIN with keyless. Now keyless comes into play where the user looks into the camera, we perform the liveness check, we extract the biometric features, locally transform them into that cryptographic quantity that is matched against the cryptographic quantity that is associated to that personal code on the server side. In this case, it is the right user that matches. We generate that device key pair, the state on the device, to cryptographically tie the device to the account. The user is again in their account, and every authentication going forward will be an inherent multi-factor authentication. Another use case, a login use case, in this case, a large Bitcoin wallet out of Switzerland, many other European countries, use keyless, among other use cases, for the login. So this is me a few weeks back in the office. I click on the login or the biometric icon, I look into the camera, and I'm authenticated with 2 factors. This isn't sped up, this is real use. You should all get an account, it's a great company. But you look into the camera, we verify the device in the background, so there's a cryptographic proof against the device key, a zero-knowledge proof against that key to assure possession, independent of passive liveness and server-side face matching, and I'm logged in. Those of you who work in the financial context, with instant payments especially, the need to authenticate payments in a strong way and assure that it was actually the user having carried out that transaction, non-disputes, mule accounts, a huge challenge we're seeing. So unlike today, where, especially in Germany, many of us use a second token app that we actually need to switch to, in some cases even log into, copy-paste the PIN code, switch back to the banking app, paste that in to send 30 euros, you could just look into the camera. We verify the device in the background, we authenticate the user and ensure their identity through the biometrics, generate that dynamic link, the unique authentication code, to sign that transaction, and we know it was the genuine account holder who made that transaction, or not anyone else. Now jumping on to the workforce side, with one example IDP we have present here at the show as well, is the login into a shared device or an account with that IDP from a user. So the user comes onto a terminal, a tablet, a company device, puts in their username, so the employee email address, in this case the password, looks into the camera of that very device, so it doesn't require a companion device. We perform the liveness check and the user is authenticated. So we know it is that very employee who is authenticating, but the employee doesn't have to have their companion device. So it's one look into the camera, but a shared device where multiple employees can authenticate into the same machine. Now, summing up, there might be anyone who hasn't heard of keyless so far. In this case, you dodged the team. We're the pioneer and the leader in privacy-preserving biometrics. We're a European company headquartered in London with offices in Rome, presence in Singapore and the US. We predominantly work with enterprises in the regulated field, but also elsewhere, and partner with essentially any relevant companies in the broader identity and fraud ecosystem. And yeah, be very happy to have a conversation with you. So if you're interested in modernizing your authentication flows, we'd be very happy of building a future of authentication where there's nothing to remember, where there's nothing to steal, and you are the key. So thank you very much for your attention. Wish you a great day ahead.
Thanks very much, Fabian, for being on time. Well, actually, slightly ahead of time. So we have some questions from the audience. So is it, I assume that means your system, also available on-prem or only on the keyless cloud?
Both. So it could be on-prem in hybrid models or SaaS in public cloud.
Okay, good. Next question is the liveness detection result generated entirely locally, or is it part of a multi-party protocol?
The liveness happens locally because we don't want any biometric data to leave the device. So both the transformation of the user's facial features and liveness happens locally on the user's device. What leaves the device is no longer biometric data, and that is confirmed by European regulators. But yeah, so short answer, yes, locally on the device.
Okay, that's great. And then we, how do you educate consumers about the privacy aspect? With passkeys, we've seen consumers being concerned that companies will get their biometric data.
Actually, passkeys have a real challenge around adoption, and there's a huge confusion between biometric authentication and passkeys being biometrics Face ID to unlock the phone, biometrics to unlock the passkey, and then sync passkeys have a whole other security issue when you look at the entire system. What we are finding is that the great thing with Face ID or Apple and Google is that face recognition is the dominant means for biometric authentication. There are some users who would ask what happens with the biometric data, but then it comes down to educating the consumers. But we've seen great adoption in the solution so far with banks across Europe and other regions.
Quick technical question is, do you integrate with Entra ID Auth?
We do.
Okay, well, that's good. And perhaps a fun question to end on. What about twins, they ask?
It's an interesting challenge. With twins, there is a challenge with any biometric system. I think what makes us different is that the twin, in order to basically circumvent the biometric pipeline and the passive liveness detection, would also need to be in possession of the same device of their twin, which makes it harder in practice. There's certainly a theoretical chance that a twin might be able to authenticate into the twin's account with any biometric system. So I'm not going to say we're the ones who stop it, but we'll make it harder than others.
Okay, everyone, please give it up for Fabian Eberle.
Thank you.